The National Electrical Code, or NEC, requires that the electrical system be grounded to the cold water pipe at the water heater or within 5 feet of where it enters the building. However, local codes may vary, so it is important to check the local code to determine specific requirements. Bonding the cold water pipe only does not prevent hot water pipes from becoming energized. This is because hot water pipes are typically connected to the cold water pipes through the water heater. If there is a fault in the electrical system, current can flow through the cold water pipe, energizing the hot water pipe. Bonding both the cold and hot water pipes at the water heater would provide an effective ground to both sides and would be code compliant if it meets the local code. This would ensure that any electrical fault would be safely discharged to ground through both the cold and hot water pipes. To bond both cold and hot water pipes at the water heater, follow these steps. Firstly, install a grounding clamp on the cold water pipe near the water heater. Secondly, connect a ground wire to the grounding clamp and run it to the panel ground bar or the main grounding electrode. Thirdly, install a grounding clamp on the hot water pipe near the water heater. Fourthly, connect a ground wire to the grounding clamp and run it to the same location as the cold water pipe ground wire. And fifthly, ensure that there is no splice between the cold and hot water pipe ground wires. Additional considerations to keep in mind include the grounding wire should be sized according to the NEC requirements. The grounding clamp should be installed according to the manufacturer's instructions, and it is recommended to have the grounding system inspected by a qualified electrician to ensure proper installation and compliance with code. Proper grounding and bonding are essential for electrical safety. Grounding creates a low impedance path for fault current to return to the source, tripping the circuit breaker or fuse and energizing the circuit. Bonding connects metallic parts of the electrical system to create an electrically conductive path, ensuring that all metal parts are at the same potential. This minimizes the risk of electric shock. The main purpose of grounding is to protect people from electrical shock. Grounding provides a path for fault current to flow back to the source, causing the overcurrent device such as a circuit breaker or fuse to trip. This interrupts the flow of electricity and prevents a dangerous voltage from being present on metal parts of the electrical system. The ground fault circuit interrupter, or GFCI, is a fast-acting circuit breaker that detects even small amounts of leakage current to ground and immediately shuts off the power. GFCI protection is required in many areas of the home, such as bathrooms, kitchens, and outdoor locations, where there is a higher risk of electric shock. Bonding is the process of connecting all metal parts of the electrical system together to create a low impedance path for fault current. This includes metal enclosures, metal conduit, metal water pipes, and other metal components. Bonding ensures that all metal parts are at the same electrical potential, which minimizes the risk of electric shock. There are two main types of grounding systems. Firstly, the grounded system, where one conductor of the electrical system is intentionally connected to ground, typically the neutral conductor, and secondly, the ungrounded system, where no conductor of the electrical system is intentionally connected to ground. Grounded systems are more common in residential and commercial buildings. The grounding electrode system is the means by which the electrical system is connected to the earth. The grounding electrode system typically consists of one or more grounding electrodes, such as a ground rod, a metal water pipe, or a concrete encased electrode, also known as a U for ground. The grounding electrode provides a low impedance path to ground, which helps to stabilize the voltage on the electrical system and provide a path for fault current to flow. The size of the grounding electrode conductor is determined by the size of the service entrance conductors. The grounding electrode conductor connects the grounding electrode to the neutral busbar in the service panel. The equipment grounding conductor provides a path for fault current to flow back to the source from metal parts of the electrical system. The equipment grounding conductor is typically a green insulated wire or a bare copper wire. The equipment grounding conductor is connected to all metal enclosures, metal conduit, and other metal parts of the electrical system. Proper installation of grounding and bonding systems is critical for electrical safety. Grounding and bonding systems should be installed by a qualified electrician in accordance with the NEC and local codes. Regular inspection and testing of grounding and bonding systems is also important to ensure that they are functioning properly. Common grounding and bonding mistakes include using the wrong size grounding conductors, improper connections, and failure to bond metal parts of the electrical system. These mistakes can compromise the safety of the electrical system and increase the risk of electric shock. Grounding and bonding requirements for different types of electrical systems can vary. For example, the grounding and bonding requirements for a separately derived system such as a generator or transformer are different from the requirements for a service entrance. The NEC provides specific requirements for grounding and bonding different types of electrical systems. Surge protection devices, or SPDs, are designed to protect electrical equipment from voltage surges, such as those caused by lightning or power line disturbances. SPD can be installed at the service entrance or at individual equipment locations. SPD diverts surge current to ground, protecting sensitive electronic equipment from damage. Grounding and bonding are essential for the proper operation of SPD. Static electricity can build up on non-conductive surfaces, such as carpets and clothing. Static electricity can be discharged when a person touches a grounded object, such as a metal doorknob. Static electricity can damage sensitive electronic equipment. Grounding and bonding can help to reduce the buildup of static electricity. In healthcare facilities, grounding and bonding are especially important to protect patients and staff from electrical shock. Healthcare facilities have stringent grounding and bonding requirements to minimize the risk of electrical hazards. Electrically isolated power systems are often used in critical care areas of healthcare facilities to provide an extra layer of protection against electric shock. In industrial facilities, grounding and bonding are essential for protecting equipment and personnel from electrical hazards. Industrial facilities often have complex electrical systems with high voltages and currents. Proper grounding and bonding can help to prevent equipment damage and personnel injury. In hazardous locations, such as those where flammable materials are present, grounding and bonding are critical for preventing explosions and fires. Hazardous locations have specific grounding and bonding requirements to minimize the risk of electrical ignition. Grounding and bonding are essential for the safe and reliable operation of electrical systems. Proper grounding and bonding can help to prevent electric shock, equipment damage, and fires. It is important to understand the principles of grounding and bonding and to follow the NEC and local codes when installing and maintaining electrical systems. The water meter should be jumpered with a bonding jumper. This ensures continuity of the grounding path if the water meter is removed. The bonding jumper should be sized according to the NEC. Gas piping should not be used as a grounding electrode. Gas piping can be damaged by fault current, which could create a dangerous situation. The grounding electrode system should be inspected regularly to ensure that it is in good condition. The grounding electrode system should be tested periodically to ensure that it is providing a low impedance path to ground. The results of the grounding electrode system test should be documented. Any deficiencies in the grounding electrode system should be corrected immediately. Grounding and bonding are essential for the safe and reliable operation of electrical equipment. The NEC provides detailed requirements for grounding and bonding electrical systems. It is important to follow the NEC and local codes when installing and maintaining electrical systems. The information provided is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician for specific electrical needs. When dealing with electrical systems, safety should always be the top priority. Proper grounding and bonding are crucial for protecting people and property from electrical hazards. Regular inspections and maintenance of electrical systems can help to ensure that they are functioning safely and reliably. In addition to the NEC, there are other standards and organizations that provide guidance on grounding and bonding, such as the Institute of Electrical and Electronics Engineers, or IEE, and the National Fire Protection Association, or NFPA. These standards and organizations can provide additional information and resources for electrical professionals. Staying up to date on the latest codes and standards is essential for electrical professionals to ensure that they are providing safe and compliant electrical installations. Continuing education courses and industry conferences can help electrical professionals stay informed about the latest developments in grounding and bonding technology and best practices. Grounding and bonding are not static concepts, and new technologies and techniques are constantly being developed. By staying informed and engaged in the electrical industry, electrical professionals can continue to improve the safety and reliability of electrical systems. The goal of grounding and bonding is to create a safe electrical environment for everyone. By following the codes and standards and using best practices, electrical professionals can help to protect people and property from the dangers of electricity. Remember to always prioritize safety when working with electrical systems. Electricity can be dangerous, and it is important to take all necessary precautions to prevent accidents. If you are not comfortable working with electricity, it is best to hire a qualified electrician. Grounding and bonding are complex topics, and it is important to have a thorough understanding of the principles and requirements. If you have any questions or concerns about grounding and bonding, consult with a qualified electrician. The information provided is intended to be a general overview of grounding and bonding principles and practices. It is not intended to be a comprehensive guide, and it should not be used as a substitute for professional electrical advice. Always consult with a qualified electrician for specific electrical needs and to ensure compliance with all applicable codes and standards. By working together, electrical professionals, homeowners, and business owners can create a safer electrical environment for everyone. Grounding and bonding are essential components of a safe electrical system, and it is important to understand and follow the codes and standards to ensure that they are properly installed and maintained.